In this video, we're going to look at the scalar product of a vector, which is also known as the dot product. Let's say we have vector A, which is equal to 2, 1, 2. And we also have vector B, which is equal to 1, 2, 4. In order to find vector A dot vector B, we simply multiply the x value by the x value, the y value by the y value, and the z value by the z value, and add them up together. So we have 2 times 1 plus 1 times 2 plus 2 times 4. And this is going to be equal to 12. And the reason it's called scalar product is when you dot two vectors, the resulting answer will be a scalar. And pretty much this formula can be generalized to if vector A is equal to A1, A2, A3, and vector B is equal to B1, B2, B3, then A dot B will be equal to A1, B1 plus A2, B2 plus A3, B3. Now, there's going to be one other formula for the dot product of two vectors. And right now, I'm going to show proof using the cosine law of this formula. And if you just want to look at the formula, then you can skip ahead using the timestamp below. But pretty much, first, let's consider we have a triangle, which is made of 3 different points. And let's say that this is A, this is vector A, this is vector B. And from the previous unit, we all know that this third length here is going to be vector B minus vector A, because this is the vector between 2 points. And what we're going to look at is, first, we're going to absolute value all of these so we can think about them in terms of length. And also, we're going to apply the rule or law of cosine, which is c squared is equal to a squared plus b squared minus 2ab cosine c. And in this case, c is going to be this side here. So if we say, first let's define each vector. So vector A, let's say, is a1, a2. Vector B is b1, b2. Then vector B minus vector A is going to be b1 minus a1 and b2 minus a2. And if we want to convert these to the absolute value, then absolute value of A is going to be square root a1 squared plus a2 squared. And absolute value of B is going to be b1 squared plus b2 squared. And finally, absolute value of vector B minus vector A, which is our third side here, is going to be square root b1 minus a1 squared plus b2 minus a2 squared, and the whole thing square root. And now if we plug these 3 absolute values in to this law of cosine, we'll get, well, first, the square from these are going to cancel out with the square root from this. So we can directly put in b1 minus a1 squared plus b2 minus a2 squared. This will be this. And this is going to equal to this, which will be these two, but with the square root cancel due to the square here. So we'll get a1 squared plus a2 squared plus b1 squared plus b2 squared and minus 2ab cosine c. And the a and b here have to be the absolute value because we absolute valued all the other ones. So this will be absolute value a, absolute value b, cosine c. And if we expand this, we'll get b1 squared minus 2a1b1 plus a1 squared plus b2 squared minus 2a2b2 plus a2 squared, and this is going to equal to a1 squared plus a2 squared plus b1 squared plus b2 squared minus 2ab cosine c. And if we look at this, we can see that the b1 cancels out here, the a1 squared cancels out here, b2 squared cancels out here, a2 squared cancels out here. So we're just left with these terms. So if we factor out negative 2 on this side, we get negative 2 a1 b1 plus a2 b2 is equal to negative 2 a b cosine c. And we divide both sides by negative 2, and we get a1 b1 plus a2 b2 is equal to a b cosine c. And if you remember, by definition, this is equal to the dot product of vector a and vector b. So this will become vector a dot vector b is equal to a b cosine c, where c will be the angle between vector a and vector b. So we're just able to prove the formula a dot b is equal to absolute value of a times absolute value of b multiplied by the cosine of the angle theta that is between vector a and vector b. And what this tells us are, well, let's consider a few unique cases first. Let's say vector a and vector b are parallel. And this would mean that theta is either 0 degrees or 180 degrees. So pretty much if a and b are perpendicular, then a dot b will be equal to the absolute value of a times the absolute value of b, since cosine theta will be equal to 1. And if it's 180 degrees, then it'll be negative. So if a dot b is perpendicular, or if a is perpendicular to b, then a dot b will be plus minus absolute value of a times absolute value of b. Now, if a and b are perpendicular instead of parallel, well, then that would mean that theta is equal to 90 degrees. And what this means is that a dot b is actually equal to 0 because cosine of 90 is 0. So whenever you try to take the dot product of two perpendicular lines or two perpendicular vectors, the answer will be equal to 0.